Welcome to the deep dive. Today, we're going to get into the weeds on something that seems small but is absolutely critical. We're looking at the engineering behind monitoring microenvironments, those unmanned server closets and data centers. And our source material today is the spec sheet for the NTI E-MICRO-TRH-TAA system.
Right, and it's that last part, the TAA, that's really interesting. It's TAA-compliant.
The Trade Agreements Act. So for you listening, that's not just some procurement detail.
No, not at all. It's a guarantee of supply chain security, which is non-negotiable for government or, say, defense installations.
Exactly. So that frames our whole conversation around a single question, really.
What are the invisible threats that this tiny box is built to see in places you can't afford to fail?
Okay, so let's just jump right in. What does it actually monitor? It's more than just a thermostat.
Oh, way more. You're looking at 6 core conditions. There's temperature and humidity, of course.
The obvious ones.
Yeah, but then you have liquid water presence, power status, physical intrusion, like a door opening, and smoke.
And the way it gathers that data is pretty flexible.
It is. So you have one temperature and humidity sensor that's built right in, but then you get 2 external RJ45 ports for other sensors, plus 2 dry contact inputs.
Okay, break down dry contact inputs for us. What does that let you do?
It's a simple but brilliant feature. It basically lets you plug in any device that works on a simple open or closed circuit.
So like a standard door alarm or maybe a water float sensor?
Exactly. It means you can integrate older non-networked gear without any trouble.
Yeah.
And all the external sensors are hot pluggable.
Meaning no downtime to add or replace one.
Right. You just plug it in.
And that built-in sensor, its operating range it's pretty extreme. -4 to 167 degrees Fahrenheit.
It has to be. Think about a remote telecom hut in the desert where the AC just died.
The temperature is going to spike fast.
And the monitor itself needs to survive that spike long enough to actually send the alert that something is wrong. That range is a survival spec.
Okay, let's talk about reliability, because that leads right into power. The standard model uses dual DC power.
Yep.
My first thought was, why not just an AC plug with a battery backup?
Yeah.
What problem did dual DC solve?
It solves for the switchover time. A battery backup has a tiny but real delay.
Wow.
With dual DC, if one source fails, it instantaneously pulls from the other source, whichever one has the higher voltage. There is zero interruption. It's a seamless failover.
And that kind of thinking is reflected in the reliability stats,
Yeah.
right? The MTBF.
Mean time between failures, yeah, the number is. It's kind of staggering. It's cited at 628,394 hours.
Which I did the math is about 71 years.
I mean, think about that. The engineering promise is that the device itself will fail once every 71 years. It's designed to outlast the infrastructure it's protecting.
And there's even a model with a third layer of redundancy, the TRHP, which adds power over Ethernet.
Right, PoE. It supports the modern standards, 802.3 AF, 802.3 AF.
But doesn't that just move the point of failure to the network switch, providing the power?
It can, but you have to think in layers. It's about options. If your primary and secondary DC sources are somehow compromised, PoE gives you a third lifeline through the network infrastructure.
Assuming your network power is also redundant.
Of course. It's all about building a defense in depth.
So an alarm is triggered, the temperature is out of range. How does this box tell someone?
It's multi-channel. You get alerts via email, of course, updates on its own webpage through network management with SNMP.
And SMS messages too.
Yeah, using an email to SMS gateway. But the real intelligence isn't just the alert, it's how you can configure it.
This is the smart alert feature they talk about.
Exactly. You can set up 32 standard alerts. If temp is over 90 degrees, send email.
But the smart alert lets you combine conditions.
Yes, that's the key. So you can create a rule that says, only send an alert if the temperature is over 100 degrees AND, the server closet door has been opened.
I see. So it connects 2 different events to give you real context.
It helps eliminate false positives and tells a much smarter story. Is this a cooling failure or did someone leave the door open?
And all this communication is locked down, I assume.
Oh, completely.
Yeah.
HTTPS, TLS 1.2, AES 2556-bit encryption. It's built for secure networks.
So to sum this up for you listening, what we have here is a tiny system that offers this really robust, redundant, and secure way to monitor your most critical spaces.
It turns raw data into really operational intelligence.
Right.
And if we want to connect this to the bigger picture, the documentation mentions you can pair it with a wireless router to create a fully wireless system. So that leaves a really important question for you to think about. How does making this kind of critical environmental monitoring wireless completely untethered from Ethernet change how quickly and where you can deploy it in the field?